But a little background on Dave. He's from Greenwood, South Carolina, and he's been married. Next month, he'll be married 35 years. Congratulations. He's got one son and one daughter who is getting married this weekend, which is why we're trying to get him on the road. He's the Global Technical Marketing Director and Business Manager for Specialty Mastics for Ingevity. It's a mouthful. He started with the company in 1984 and has held positions in sales and technical management. Also worked in tech management for Coke Materials, Sem Materials, and Hall Brothers. He's very active in the industry. Most of you may know him by now, but he's going to be giving a presentation on ensuring quality and mixed designs for microsurfacing and slurry seal. So, y'all welcome Dave Neward. Well,
Well, Mark, it was actually pretty easy for me to decide which session to come to since I had agreed to speak at this one. So it's really an honor to be here. And while I'm from Ingevity, the fact that Bob is the ISSA technical director is really the driver for his being selected for this particular session. And so the ISSA, I'm a board member there as well. We want to share with you the point of view we have toward quality and how we engage with the industry for that, for slurry seal and microsurfacing designs. So, Bob isn't here, and we know why. About a week ago, we started seeing this kind of thing out on the East Coast, and at the end of the week, on the weekend, we had Hurricane Matthew come into Charleston, and I was driving over on Sunday and talked to Bob, and he was still planning to be here, and I said, the flights coming in on Monday morning may be a little difficult, and you do have a lot of damage, but on Monday he did find out that his flight was canceled and that I was prepared to do this presentation for him. He sent it to me, and I made a couple of adjustments, but so we have a contingency plan. It's pretty common in the asphalt industry and the road construction industry. Weather does impact our lives, and so it impacted ours this week. So we talked about ensuring quality mix designs. Well, ensure by definition states that it's to guarantee or to make certain. And a very wise person in our U.S. history, Benjamin Franklin, stated that in this world there's nothing that's certain except for death and taxes. He didn't include quality mix designs. So as part of the contingency plan here, we're moving on to make an adjustment in the title to enhancing quality of mix designs for microsurfacing and slurry seal. And I did add my name as the presenter for today's session. When you look at the quality of mixed designs, how do you get better quality in mixed designs? There's a couple of different perspectives you can take toward that topic. First one are the tangibles, things like the raw materials that you use, the guidelines, specifications that are really part of the performance specs that tell you that you're going to get performance out in the field. And then what's the quality of your laboratories that are doing this, the lab accreditations. These are things that are tangible. And then there's some intangible aspects of this as well that are, we'll go into that in a little more detail, but some of the human factors that come into play when you start talking about mixed designs and the quality of the mixed designs. So as we look at tangibles, raw materials, you're looking at aggregate, you're looking at emulsified asphalt, which has asphalt, water, the emulsifier, additives, or the acid or the base that you're using, polymers, and asphalt additives. And then you have the mixed water that's used in the slurry or the microsurfacing mix, mineral filler, and other additives that are used to control break and mixing in the field. And all of these are very, very critical. So when you start looking at it, how do they come together? Well, it's ultimately a system. It's a systems play. It's, you can take materials that work with one group over here, change them out, they don't necessarily work right. So you've got to have the right raw materials at the right ratios or proportions and in the right order of addition. And the right raw materials really goes into a critical thing called sampling. So the sampling on the very front end of what you're going to use in that job has to be has to be performed. So let's talk about a few of the specifics on these raw materials. As we look at aggregate, you're looking at the fines, the reactivity is the surface charge of that aggregate. So most of them are on the negative side, most aggregates. Some have a positive charge on the surface, but the ultimate reactivity of these fines, of these aggregates, are going to be controlled by the fines that's in the mixture. Not only the quality of the fines, but the quantity. So if the quantities are moving around on you, you're going to have some issues in the field. And I don't know if you've been in this industry for a while and you see loads come in where you've got 2 or 3 or 4% swings in the passing 200, or for those in metrics minus 0.75 microns. You've got a lot of problems in the field when you have that kind of variability. The gradation, when we look at it for ISSA, it's types 1, 2, and 3. And then you have some local specifications that may be a variant thereof. And in other parts of the world, it can be different, quite different from that as well. But the gradation curves that you get are defined for the kind of performance you're looking for in the field. So make sure that these materials are meeting those criteria so that you aren't making unnecessary adjustments out in the field. And then ultimately you've got shape. You want 100% crushed recommended for fractured faces on these aggregates. And the cleanliness really plays a big role. What's the methylene blue value? What's the sand equivalent value of these materials? If you get high reactive clays in these mixtures, you're fighting them all the time. So you need to understand that and try to get as high a quality of these aggregates as you can. Also soundness and LA abrasion. You want durability in the field so that when the agencies put these materials down, they last and perform like they expected. So we're starting with good aggregates here. Then moving on to the emulsified asphalt, another super critical part, very near and dear to my heart since we provide emulsifiers and additives for this industry. But the asphalt, it's super critical. One asphalt can work great with one aggregate, and it may not be a great asphalt for another one when you make the emulsion. But the crude source is critical. The way that the refineries process the material is critical. What are some of the chemical makeups of this? And really, chemical companies are going to talk right now. Asphalt is a chemical. Sometimes we don't think about it that way. The aggregate is a chemical. So in these emulsion systems, the chemical interactivity is critical. And maybe in hot mix, we don't think about it quite as much, but it's really, really critical in these emulsion mixtures. The emulsifier that you choose. Is it an anionic, cationic? What's the dosage rate? What are the types of performances that you typically get from those types of materials? What's its ease of use, its solubility? How readily available is it? Those are critical things that you need to consider in putting these materials together. And all emulsifiers aren't the same. They're not necessarily interchangeable. So if you start out with one type of chemical system, you need to be prepared to stay with that throughout this design that you have. The polymers that are used in some of these mixtures, whether it's microsurfacing or a polymer-modified quick-set slurry, you can have natural latex, SBR latex. Sometimes you'll have an SBS-modified asphalt base before you make the emulsion. And all of these will perform in different ways. They're not necessarily interchangeable, but if you know these things on the front side as you're starting these designs, and performing the mixed designs in the laboratories, then you'll end up with materials that will perform as you propose in the field. And then one thing we tend to overlook sometimes is the water. We talk about water being potable, something that's reasonable for drinking maybe, but the water cleanliness needs to be consistent when you're doing your design work in the laboratory with what you would see at the point of production for these emulsions. And hardness and mineral additive or dissolved minerals in these The water source can be a significant player in the way that it performs for emulsion stability, emulsion quality. You've got to have good water, good asphalt, the right kind of chemistry and polymers so that your material starts out good and stable. You want to have a good emulsion. And then other raw materials. We're going to talk about water again. It's used in your mixture when you're doing the mix in the machine to lay down the microsurfacing or the slurry seal. And so that water needs to be something that's not too different than what you'd use for your emulsion. It needs to be clean and free of any deleterious materials. And so in the design process, you still want to include materials that you expect to see in the field. The mineral filler. Typically, you'd use cement. Sometimes you'll use hydrated lime, but this is an area where you can fall into a trap. Sometimes we've seen materials, cement by nature likes to hydrate. So if you've got cement that's been sitting around in a humid environment, Charleston's a humid environment. It's also flooded sometimes. But if you've got a lot of moisture in the air available, it can start to react with that cement, and it becomes less reactive in your mixture. So if you've got to maintain freshness in that cement additive that you're using in the lab, as well as in the field, because those materials are critical in that chemical reaction process that's going on as you're making microsurfacing or slurry seal in the field and putting it down. So get it right in the lab and in the field. And then there are additives that can be used within the process to control break, control mix times, to be able to accommodate extreme heat conditions that you sometimes see in the summer, and be able to do that through the course of the day. But these additives, again, that you might utilize in your laboratory design need to be consistent and reflect exactly what you're going to be using out in the field. And a good design will look at these and also give that information to the end user so that he will know how much he can use and how much he shouldn't use, what amount is too much. More raw materials. We're talking about the system again, the right materials, the right ratios, and the right order of addition. Sometimes you don't think about ratios or even order of addition that much, but the ratios are super critical. As you do your design, you'll start with, is it 10% emulsion? Is it 12% emulsion? What's going to be your ideal rate? And even looking at the emulsion itself, is it a 60% or a 65% solids? You really need to understand these things when you prescribe that information to the producers and the contractors that put it down. So the ratios are the critical part of the reactivity, but then the order of addition, that seems kind of common and shouldn't even have to bring it up. But we have seen times when people think that you can add the water later or earlier or whatever. It does behave differently. Once you start a breaking process of that emulsion, if you don't have enough water to start with, you would have a situation where you would have some material that's already broken, and it's not going to remain consistent in film formation in the field. So laboratory, order of addition, prescribe it very distinctly to the operators that are going to be putting it down. Some more tangibles. You got things like your specs and your guidelines. ISSA provides guidelines to be utilized by agencies to develop their specifications, and very absolutely, they are guidelines. They are not in and of themselves specs, because the specs need to take into account the local needs, different climatic conditions, maybe different scenario or types of materials that you see in some regions, and those things need to be accommodated in the specs. But we do have our guidelines that we provide, and and they've been used very successfully around the world. You've got a few things listed here in some of the countries, and in my job, I have the privilege of going to different parts of the world, and ISSA has been highly recognized in many, many parts of the world, and they'll utilize these guidelines to put their specs together in those countries. And by using these kinds of guidelines and spec developments from the guidelines, we've seen millions and millions of square yards of very successful application in places like China, Brazil, India, Southeast Asia, Australia. They've been used many places around the world. But that needs to be adjusted at the local level for what the need is. And then here in the U.S., we have started putting some new standards together and specifications. The AASHTO has put the microsurfacing standard spec for materials and provisional standard practice for microsurfacing design into place just recently. And that was done through the help of the emulsion expert task group, the emulsion task force. And also on the emulsion specification amendments, we've got now emulsified asphalt, cationic emulsified asphalt, and polymer modified cationic emulsified asphalt. Again, these are put together from the government in coordination with industry to get the best specifications out there that are used as part of that recipe manufacture in the mix design so that you get the right product out on the field. Something else too, you may not recognize this name. ISSA, of course, is International Slurry Surfacing Association, but then you've got Resource Partnership. We've got the ISSA Resource Partnership. Resource, formerly known as AMRL, but I was notified by one of the speakers today and a colleague that we've been working with in this partnership that this has changed as of August. So Resource is now part of a partnership with ISSA. We've utilized them to go in and do some certification for our laboratories, accreditation of our laboratories. So they're going in doing the evaluations of our laboratories that do the mix designs. We want to make sure that the laboratories themselves have the right procedures in place, the right kind of processes. They understand how to utilize the equipment appropriately. They understand and interpret the specifications and procedures correctly. And, it's really an eye-opening thing because when you've lived in the industry for a long time, I've been around for over 30 years, and you assume a lot of things. You think that words are in a spec or in a procedure that may not really exist. And so as we had fresh eyes coming into this process, they took a look at some of the ways that we described how to do a procedure. And there was ambiguity. And ambiguity is not going to lead you to that higher quality mix design. So we've made adjustments in some of the wording that we utilized. And that's a simple thing. Other things, though, are as you do this, you start to see maybe ways you can have a better test, ways that you can put a different procedure in place that's even more indicative of ultimate performance in the field. And as we're starting into these lab evaluations from Resource, we are going to be seeing things that we can do and enhance the quality of the laboratories that are putting these designs together for everyone. And then there's a category that Bob put in called intangibles. And the easy things are the tangibles. The intangibles, though, are a little more nebulous. You've got a couple of these, like the cheaper does not equal better performance. We live in a world where low bidder usually wins. So that means cheaper wins, but it doesn't necessarily mean higher quality and performance. But that is one of the constraints that we have in our industry. And just in time does not necessarily apply for high quality. you need to have materials in hand long enough to perform a 6-day soak. And if they give it to you and need a design in 3 days, it just doesn't happen. So, and on the, you know, these are economic drivers that sometimes impact quality. It's a reality of life, but those are things that you need to consider. And if we can if we can take effort to try to get beyond that, we will end up with better quality designs to provide better quality road and pavement preservation processes. And then really, as you look at some of the rest of the things that he has on the list here, you got integrity, do the right thing. Man, these are people issues. And no matter what, you can have your systems in place, but people perform it. And so the people in the laboratories need to have high integrity and really care about the output of what they give you for that road application. Some people have it and some people don't. And that's one of the things I think that as you move forward with even some of these accreditation programs, you'll start to see areas that you can shore up and make sure that the people that are providing you this information is giving you the very best and honest data that you can do your road activities with. Understanding partnership. We have partnership with Resource. We have partnership with the different groups that are here with the National Center for Pavement Preservation, ISSA has. And I think that as you look at laboratories, they need to partner up, make sure that they're seeing this as a partnership with the contractors and with the agencies, because everybody's end game should be the same thing: a quality application on the road. What's going to drive the industry, what's going to give the driving public the best bang for their buck, what's going to keep that road intact and high performing for years to come. It's through a partnership, and it shouldn't be adversarial. It shouldn't be one of the using a stick to beat people up at either place. So understanding partnership is critical. The industry hat comment, that's one thing that we do in our board with ISSA. Even though we work for companies that have very specific stakes in this industry, when we're representing the board, we put on our industry hat. And I think that the laboratories need to put on the industry hat. What's best for the industry? Not necessarily only my company. If you're good for the industry, it's going to benefit your company. So put on that industry hat. Have passion for what you do, because people that are passionate do great work. People that are impassionate, who knows? But passion is critical. And then ultimately, if you've got those qualities and the character of the people that are involved with putting these designs together, you'd leave a worthy legacy behind, because you would have projects in place that performed well. You would provide materials to the contractors so they could be successful. The agency wins, contractors stay in business, they make money, they've got good product on the road, the driving public is happy because the roads are performing like they want. So these intangible things, you can't mandate them, but boy, they're sure great when you find them. And this is the kind of thing that if you get the right tools on the front side with those tangible things, and you couple those with the intangibles that we have here, then you'll end up with a much higher quality mixed design that's then used and successfully applied in the field. And so, in kind of drawing all that together, it really kind of comes down to ownership. And only, this is kind of a catch, but only you can ensure a quality mix design. And it's really true. You've got the people in the lab, but then the agencies in the field, they need to be very adamant about owning this whole process and making sure that it works right. So with that, I thank you on behalf of Bob. I thank you also on behalf of my daughter Amanda, who will be married, and I'll be in the rehearsal tomorrow afternoon. And again, thanks so much for your time and attention. This is Bob's contact information. You see it there. So, huh?
If you have any questions, call Bob.
Yeah, well, you can call me, and I'll actually have a phone that's a hands-free phone in the car, and I'll be glad to talk to you on the way home.
Yeah, you have plenty of time to talk. Does anybody have any questions about general quality? Well, thank you everybody. Give them a hand. Thank you very much.
Thank you, Mark.
Have a safe ride.